In this question, we are given a signal xt equal to sine 4 pi t divided by 4 pi t, and we have to find out energy of this signal. So energy of any signal xt is modulus of xt square dt integration from minus infinity to plus infinity if signal is given in time domain, and in frequency domain the energy is 1 upon 2 pi from minus infinity to plus infinity modulus of x omega square d omega. Okay. Xt may be a real function of time or a complex function of time. If it is a complex function, we have to take modulus. In similar way, x omega may be a complex function of omega, so in that case we will have to take modulus. If it is real, then taking modulus is not required. Okay, so when you will put xt equal to this sinc function, this way calculating this integration is difficult, so we will use this method. First we will find, for this xt we will find x modulus of x omega, and then we will try to calculate the energy. So to find out the Fourier transform of this signal, I am first taking a time domain signal which starts from minus k in time domain and ends at plus k. Let's say this is xt. Its Fourier transform will be 2 sine k omega divided by omega. Okay. This signal starts at minus k second and terminates at plus k second. So its Fourier transform is 2 sine k omega divided by omega. I am applying duality theorem. If xt it has Fourier transform of x omega, the small xt has a Fourier transform capital X omega, then the capital xt, this will have Fourier transform 2 pi into small x minus omega. Okay, and if xt is even function, then x minus omega will be x omega. Okay, so let's say this is capital X omega. Means capital X function means this type of function, so this will be capital X t. So capital X t will have the Fourier transform of capital X t will be 2 pi small x omega, and small x t is this. So here we will have minus k radian per second to plus k radian per second, and height will be, this will be multiplied by 2 pi. Then what will be the Fourier transform of sine kt divided by kt? Its Fourier transform will be, the Fourier transform is linear operation. So what I have done, I have divided this function by 2. First I divided by 2, then I divided by k. So this will be divided by 2k. So here we will have minus k2 plus k, and the amplitude will be pi divided by k. Now the energy of this signal will be sine kt divided by kt whole square dt from minus infinity to plus infinity. This will be equal to integration from minus infinity to plus infinity 1 divided by 2 pi, and this function square. So what is this function? Let's say this is minus k2 plus k pi by k whole square d omega. This will be 1 upon 2 pi. It starts from minus k, so lower limit will be minus k, upper limit will be k, pi by k whole square d omega. Since pi by k is constant, so it will be taken out. This will be 1 upon 2 pi into pi square by k square into integration of d omega from minus k to plus k. This will be pi divided by 2k square into, here you will have 2k, so 2, okay. So we have energy of this signal, energy of sin kt by kt is pi divided by k, and in this question at the place of k we have 4 pi. So energy of sin 4 pi t divided by 4 pi t will be, this will be pi divided by, at the place of k we will put 4 pi. Energy of this signal will be 0.25. In this question we have a continuous time filter with a transfer function of 2s plus 6 divided by s square plus 6s plus 8, and this continuous time filter, this has to be converted to a discrete time filter with transfer function gz equal to this. Here in this filter we have k as unknown, so this continuous time filter has to be converted to this discrete time filter such that the impulse response of the continuous time system, when the impulse response of this filter is sampled at 2 Hz, okay, that sample of impulse response of this filter has to be identical at the sampling instant to the impulse response of discrete time filter. The question is, we have a continuous time filter and its impulse response, there will be some impulse response ht, so that the impulse response of continuous time system, so the ht is the impulse response of continuous time system, and when ht is sampled at 2 Hz, when it is sampled at 2 Hz, this should be identical at sampling instant, okay. This should be identical to the impulse response of discrete time system, and here you have discrete filter, here you have hs and here you have gz, and here you have del n, okay. And let's say the output here is, let's say gn. So at sampling instant, the sample of ht at 2 Hz, this should be identical to gn. So let us first find out ht, okay, when ht is nothing but the impulse response of continuous time filter, and then we will sample that, okay, and this sample has to be equal to gn, so the samples will be nothing but gn, then we will take z transform of gn, and z transform of gn will be nothing but gz. So from here we will find out gz, and we are given with gz, and we will compare the two gz, and this way we will find out the value of k. So first let us find out the impulse response of this continuous time filter, okay. So here the output hs, if the input is del t, the Laplace of output will be equal to the hs, the transfer function. So here output is, or the Laplace of output is nothing but Laplace of input into hs. Laplace of input is nothing but 1, so output will be hs. This is 2s plus 6 divided by s square plus 6s plus 8. If you will take partial fraction, after partial fraction we will have 1 upon s plus 2 plus 1 upon s plus 4. So the output ht will be, or the output yt will be, yt is e to power minus 2t ut plus e to power minus 4t ut. Now the question is, the impulse response of this continuous time filter, this is sampled at 2 Hz. This is sampled at 2 Hz. So after sampling, this will become discrete signal. Let's say this will become yn. Now if this signal is sampled at 2 Hz, it means in 1 second we have to take 2 samples of this signal. So let's say we are starting with t equal to 0. So the first sample will be y0, and y0 will be e to power minus 2 into 0 u0 plus e to power minus 4 into 0 u0. The next sample will be y0.5 this will be e to power minus 2 into 0.5 u 0.5. okay, all the value of u will give you 1, so it is better to put 1 here. It is not the u0 or u0.5 is not necessary to write here, because its value will be 1. So here you will get e to power 4 into 0.5, and instead of u0 we will write for t greater than 0. Similarly, the third sample will be y1, and this will be written as e to power minus 2 into 1 plus e to power minus 4 into 1. Okay, in discrete time this will be represented as y0, and in discrete time we have to represent it as integer. So this is first sample, this is second sample, this will be y1, this will be y2. okay, so y0 is equal to this, y1 is e to power minus 2 into 0.5. Similarly, y2 is e to power minus 2 into 1. So this way we have to find out yn. So what will be the general expression of yn? You have 0 here, this 0, 0, 0. If you have 1 here, here you have 0.5, it means 1 by 2. Here also you have 1 by 2. If you have 2 here, here you have 1, it means 2 by 2. 2 by 2. So if you have n here, this will be e to power minus 2 into n by 2 plus e to power minus 4 into n by 2 for n greater than 0. So yn can be represented as e to power minus n un plus e to power minus 2n un. Okay, so if this continuous time signal is sampled at 2 Hz, and if you have to obtain the discrete time signal, the corresponding discrete time signal, if the sampling frequency is 2 Hz, then you just have to put t equal to n by 2, you will get yn. Similarly, if frequency is f here, you have to put t equal to n by f, you will get the discrete time signal. Okay, so this is nothing but this is impulse response of continuous time system, the impulse response of continuous time filter when it is sampled at 2 Hz. This is impulse response of continuous time filter, and this is sample of the output of the filter, and this has to be identical to impulse response of discrete time filter. This has to be identical to impulse response of this has to be equal to impulse response of discrete time filter. Discrete time, this has to be equal to impulse response of discrete time filter, and satisfying this condition we have to find out the value of k. So here you have discrete time filter given by this equation, and if you have given a discrete time impulse to this filter Hz, the output is this Yn. Okay. Let's say the output is Yz. So Yz will be Z transform of del n, that is 1 into Hz. So Yz is nothing but Hz, and what will be Yz? The Z transform of Yn. So basically what we have to do, we will take Z transform of Yn and we will equate that to Hz that is given in the question. So what will be Z transform of this signal? Z transform of a to power n un is Z divided by Z minus a, and at the place of a we have e to power minus 1, e to power minus 1 to power n un. So its Z transform will be Z divided by Z minus e to power minus 1. Similarly, Z transform of this will be e to power minus 2n un. This will be Z divided by Z minus e to power minus 2. So Z transform of this signal Yz will be Z divided by Z minus e to power minus 1 plus Z divided by Z minus e to power minus 2. This is Z into Z minus e to power minus 2 plus Z into Z minus e to power minus 1 divided by Z minus e to power minus 1 into Z minus e to power minus 2, and this Yz has to be equal to Gz. This has to be equal to Gz. So this will give you Z square minus Z into 2Z square, Z square plus Z square minus Z into e to power minus 1 plus e to power minus 2 divided by Z square minus e to power minus 1 plus e to power minus 2 into Z plus e to power minus 1 into e to power minus 2. This will be e to power minus 3. Okay, and the value of e to power minus 1 plus e to power minus 2 is 0.5032. This will be 2Z square minus 0.5032 Z divided by Z square minus 0.5032 Z plus e to power minus 3, and this has to be equal to Gz. Now if you will compare, value of k will be, value of k is nothing but e to power minus 3. Okay, and this is approximately 0.05. So k will be 0.05. In this question, xn is a 4-point sequence 3 2 3 4, and its DFT pair capital Xk is given as 12, 2j, 0 and minus 2. So the discrete time signal xn is given, and its discrete Fourier transform pair capital Xk is given. Next we have x1n is given, a different discrete time signal, and its discrete Fourier transform pair is x1k. So we have to find out x18 divided by x111. Okay, so one method is simply x1n is given. Okay, so calculate x18 and x111. x1k will be summation xn e to power minus j k omega naught n, and n is varying from, this will vary from 0 to 11. So x18 will be 0 to 11 xn into e to power, at the place of k we will put 8, and omega naught will be 2 pi by capital N, and capital N is 12. This is a 12-point sequence. This will be 2 pi by 12. This is pi by 6. So here we will have minus j k equal to 8 into omega naught equal to pi by 6 into n. So x18 will be from 0 to 11 xn e to power minus j 4 pi by 3n. Okay, so x18 will be, when you will put n equal to 0, x0 is 3, so you will have 3 into, and since n is 0, so this will be 3 into 1. Next, when you will put n equal to 1, you have x1 equal to 0. Similarly, x2 is 0, so the next value of n, that will give you a non-zero value, that value of n is 3. So next we will put 3, and when n equal to 3, xn is 2. This is 2 into, and when you will put 3 here, this will give you e to power minus j pi by 4. E to power minus j, sorry, 4 pi, not pi by 4. Okay. Similarly, this is n equal to 3, n equal to 4 you will get 0, n equal to 5 you will get 0. Next value of n is 6. So when n is 6, you will get 3 here, and when n is 6, you will get e to power minus j 8 pi. Similarly, 6, 7, 8, 9. xn is 4 into, when you will put 9 here, you will get e to power minus j 12 pi. Okay, and again the next two values are 0. So this way you will get x1 8. E to power minus j 4 pi, this will give you 1. This is also 1. This is also 1. So 3 plus 2, 5 plus 3, 8 plus 12, 4. This will give you 12. Similarly, we will try to find out x1 11. So at the place of k we will put 11. It will be 0 to, n will vary from 0 to 11. xn e to power minus j k equal to 11. 11 into omega naught is, omega naught equal to 2 pi by 12 pi by 6. So this will give you 11 pi by 6 into n. And 11 pi by 6 can also be written as 11 pi by 6 minus 2 pi. So this will give you minus pi by 6. So this will be 0 to 11 xl e to power, at the place of 11 pi by 6 we will put minus pi by 6, minus minus plus j pi by 6 into n. So again, starting from 0, x1 11 will be, when you will put n equal to 0, you have 3 non-zero, 3, and if n is 0, here you will have 1 plus, then the next value will be 1 is 0, 2 is 0, 3, x3 is 2, and when you will put n equal to 3 here, this will give you e to power j pi by 2, e to power j pi by 2. Next value is for n equal to 6, 3 into, when you will put n equal to 6, you will get e to power j pi, and next value is 9, and x9 is 4 into e to power, when you will put 9 here, you will get e to power j 3 pi by 2. So this is 3 plus e to power j pi by 2 is j, 2j plus e to power j pi is minus 1, minus 3 plus e to power j 3 pi by 2 is minus j. 3 and 3 are cancelled, this is minus 2j. So the answer will be x1 8 is 12 and x1 11 is minus 2j, and its modulus will be 6. So 6 will be the answer.